Step 1. Obtain 2 open-ended
1
capillary
to 2
tubes.
mm of naphthalene into a capillary tube. Tube into the slot in the heating block of the melt station.
Start data collection.
1 bromo 2. So that was a 2 bromo 2? Yeah.
On the melting station, turn the knob to a setting of 180 degrees Celsius. Carefully observe your sample. If the solid begins to melt, click mark to mark the temperature on your graph, or press D on the computer. When the entire solid has completely melted, click mark again. Those 2 values marked on your graph describe the estimated melting temperature range of your substance.
At 20 seconds.
If the solid does not melt, by the time the temperature hits 150, turn the knob to a setting of 220 degrees Celsius. Continue observing your sample, and if the sample begins to melt, mark the temperature on the graph in step G. Record the melting point in your lab notebook.
Highly reactive, but non-instant. I didn't really see any point.
On the melting station, turn the control knob to the fan cooling setting and get ready for the next step. Repeat steps A through H with benzoic acid. Create a calibration graph.
To the pre-lab or the
Obtain 4 capillary tubes.
Place a pea-sized amount of acetanilide, phenidicin, silicic acid into a separate test tube.
Determine the melting point range of acetanilide, phenacetin, and salicylic acid. Record your results. Obtain an unknown. Take a small amount, 0.1 to 0.2 grams of your unknown mix, and mix it with the same amount of acetanilide. Pulverize the sample by crushing it with a metal spatula and place it into a capillary tube. Repeat step B and C with phenacetin and salicylic acid. Record the melting point range of each sample and determine the identity of your sample.
If the apparatus was calibrated correctly, the melting point closest to the original temperatures recorded would help you determine which unknown is which.